Cambridge International GCSE Chemistry, Paper 6, Preparation, Separation Methods and Purity. So we will run through the methods by using an example, the preparation of pure copper sulfate crystals. So the method is adding excess copper oxide to hot sulfuric acid and stirring. You have to understand why it's excess copper oxide so that all of the sulfuric acid has reacted. To obtain pure copper sulfate, we need all of the sulfuric acid to have reacted. So here's our diagram, copper oxide, hot sulfuric acid. What is the name of the heating instrument? It's a question on paper 6. It's called the Bunsen burner, of course. What is the name for this piece of glassware? Again, it's a question that comes up. It's a beaker. So we stir the copper oxide. There's an excess. We know that because some of the copper oxide remains unreacted. We have some black solid remaining. So we filter off the excess copper oxide and we produce a filtrate. That filtrate is a purified copper sulfate. So the third step is to heat the copper sulfate solution, the filtrate, to evaporate excess water. So here is our diagram. What is the name of this piece of apparatus which is holding the copper sulfate solution? Okay, it's an evaporating dish. A further detail, often questioned on paper 6, when do you stop heating? It's when crystals first appear on the sides of the evaporating dish. It's called the crystallization point. Having reached the crystallization point, remove the dish from heat and leave to cool, and crystals will form. Now, we've got probably some excess copper sulfate solution, so to obtain pure copper sulfate crystals, we need to filter and then wash off with distilled water any remaining copper sulfate solution holding to the sides of the crystal. So, as an exam answer, our last step is filter and wash, and then you leave to dry to get your perfect pure copper sulfate crystals. Let's talk about distillation. Rather than obtaining pure salt crystals such as copper sulfate from the solution, it's possible to obtain pure water from a solution by distillation. So let's imagine that we've got our purified copper sulfate solution from the previous slides. How would we obtain pure water? Well, we'll place the copper sulfate solution into a flask with this arrangement. What is the name of this piece of apparatus that I am highlighting? It's a condenser. If I'm collecting pure water, what would be the temperature reading on the thermometer? It would be 100 degrees Celsius or very close to that. So to obtain pure water, we heat and evaporate the water from the solution, which passes through the condenser, turns back into the liquid, pure water. Copper sulfate would remain in the flask. So if we've obtained some water from the distillation of copper sulfate solution, how could we confirm that it was pure? we could produce a heating curve for the water sample, and this is an item in paper 6 examination. When a liquid such as water is heated, the temperature rises to reach a maximum at which the liquid changes state to a gas. In this case, water forms steam. So we get a plot something like this. The horizontal section corresponds to the boiling point, and if it is at exactly 100 degrees Celsius and we have a perfectly horizontal plot, that indicates that the liquid is pure water. So in paper 6, cooling curves are also examinable. So horizontal plots at state changes are also obtained as we change steam into water and then into ice as we cool. So we get a plot something like this, where we start with steam, we're lowering the temperature as time progresses, and we get two horizontal plots that correspond to the state change. This, of course, at 100 is the plot corresponding to the boiling point. So steam condenses into water at its boiling point, 100. If we also get a second horizontal plot as the liquid water forms solid ice, it freezes. That happens at the melting point. If it is exactly 0 Celsius, that again indicates that the substance is pure water. Some precise knowledge of the terminology in paper 6 separations is advisable. So think carefully about each of these words centrally and decide on which of these definitions to the right or to the left best matches the term. Pause, think it through, come back to check your answers when you have completed. Okay, so let's go through. The liquid which passes through a filter paper is the filtrate. A liquid in which the solute dissolves is the solvent. The solid that dissolves in the solvent is the solute. Solutes that dissolve in the solvent are said to be soluble. A solute that does not dissolve in a solvent is said to be insoluble. A solid collected, for instance, in a filter paper is termed a residue. The process of a solid and solvent forming a solution is dissolving. A solute where no more can dissolve is called saturated. And a mixture of solute and solvent that does not separate is a solution. So obviously at this point, with the paper 6 coming up, you need to complete some past paper questions from paper 6. If you found this lesson helpful, please recommend to a friend. And if you're inclined, please like and subscribe.